Hi all, hope you all can hear my voice very clearly. And today we are going to discuss about OpenShift, Red Hat OpenShift technology. Um, so why OpenShift, right? And also I'm going to discuss about the concept of how the communication, right? The applications already running inside of OpenShift product, which is inside container. So how the externally the users can access the application which is running on the container inside OpenShift, right? So the what is the communication flow and what all components is required, right? And and how the communication flow exactly from external to internal OpenShift container where the application is running, right, and the last layer. So how it is communicating, so we are going to discuss. So and like why suddenly I have taken this particular discussion is I just did one troubleshooting related to networking. I thought of let's go with some like communication flow discussion with you guys. So that's the reason I started with this, right? So the heading of today discussion is we will discuss a lot of things like the all the components and like it's very simple way which is very understandable and even easily we can remember and uh, uh, understand the product and the communication things, right? So this is very simple, not too technical things. I'm not going deep technical, but also it is a deep technical things only, what all components involved, how the communication flow, but it will be like easily understandable, I hope. So let's go. So basically we are going to discuss about OpenStack, right? Sorry, not OpenStack, sorry, my bad. So OpenShift product we are going to discuss. Okay, so in this the particular concept we are going to discuss is how the communication happening from external to internal, right? So this is what we are going to discuss today in the simple way. If you see like another 10 minutes, you will understand how the communication is happening when user try to access the application via browser, and what all the things it is hitting, and it get crossed and reaching the final application and getting a response to the user, right? So this is what we are going to discuss. So if I go to this continue further, I'll just go with this, right? Yeah. So the first thing, right? So first thing is like user. Okay. So user user I can just say user browser, right? Yeah, user browser. So user browser, what he will do, right? So user he will use the browser to hit the request, whether it may be a HTTP request or it may be a secure request, right? HTTPS, right? So this is the request, right? So sample like some service, right? Any service, like let's take payment, right? Payment dot apps dot, like our domain, right? Like something like .com, payments apps.com, right? This is what the user hitting the request. Okay, this is user hitting the request. So when this request user hit, right? So what will happen? So this request, what will become is, so there is a DNS conversion is happening, right? DNS conversion. So you know DNS, right? Domain name server. So each domain name has the actual backend IP, right? So that's what happening. So when user hit the URL, so this URL actually a IP address which the conversion happening. So there is a domain name server IP behind the URL, right? This is a domain name basically. So behind this domain name there is IP. So there is a DNS conversion happening. So then this this request goes to OpenShift router, OpenShift router, right? So this request goes to OpenShift router where there is a Ingress controller component available which has HA proxy, HA proxy running, which has HA proxy running. So this is basically a load balancer, right? So load balancer in OpenShift, right? So this request, what this OpenShift Ingress controller will do is this will take the request. This will which means like it's accept the request. This will accept the that incoming request, right? This will accept the incoming request. This will also match the request to correct hostname and path as well, right? So this is what the request going, right? Then route is coming into the picture again. Route, this is a router, we call it as, which has the ingress controller accept the incoming traffic and match the request to the exact host name and path. And HA proxy will act as a load balancer which is available inside ingress controller, will distribute the traffic based on the request load, right? The how many people currently trying to access the application. So based on that it will distribute based on the container replicas available, right? So then it comes to route. So basically routes will decide this request where should go, right? So this request where should go, that routes will decide basically. And then comes to the service is nothing but cluster IP, right? Cluster IP. So this is like a internal load balancer, we can call it as internal load balancer, we can call it as internal load balancer. What actually it does is this will receive the request, right? Receive the request from the router, select the actual backend pod, using the labels, because every route definition has the label of the application name, right? So based on that, this will distribute the traffic. So so for example, this particular payment service, based on the label, whether pod 1 or pod 2 or pod 3, right? So this will distribute the request, right? Pass through will take it as, right? So then last is pod, so which comes into the actual application where it is running, pod, right? So inside pod, actually we have the containers. We will talk more on this like later. So this is just for the only the communication flow we are discussing about. We'll discuss about pod, containers, and even further things like later. But just simple for you to understand very simple way, I'm just giving you this understanding. And also I will also put some architecture flow here itself, so then you can understand much more better. And also some components I'll explain what are the things, it's taking care of it. So pod, and we have the container runs under this pod, right? So this pod will receive the request from service and then process the business logic according to the code, application code, and then sends the response back to the browser. It's the same flow. Then pod to service, then route, and then load by HA proxy, then it goes to browser response, right? So this is the actual response flow. So basically what's happening here is, so we discussed about DNS, which will converts the URL into IP, right? So then we discussed about load balancer, which is HA proxy, distribute the traffic to routers, okay. Then route mapping rule we have in the route only, which means URL to service. Then we discussed about service, which is internal load balancer. Then pod runs the application, right? Where application, okay. So this is what the actual flow is: DNS, router, and then route, and then service, then pods, then the response flow also the same way, okay. So we will also discuss about, so the another thing, another part, there are multiple things which I want to discuss in the networking part. So, for example, what is dual stack, and then what is network interface and network as well, and what is VLAN, and what is gateway, and then what is multus, then what is something called whereabouts, srio, and then also we have static. These are all the network types basically. So then what is OVN, then what is cube proxy, then what is HA proxy again, we already discussed about this, just I'm giving this. Then what is Ingress Controller, yeah, again I already discussed with this as well, but separately also we'll discuss about few points. What is route, what is network attachment definition, what is port, what is switch, then what is service and service IP, then what is IPv4 and IPv6, then what is cluster IP, again, right, what are the components involved in the entire communication flow, and then for example inside pod to pod, same node, how communication is happening, again it's internal, then pod to pod, different node, how the communication is happening. So this all, like, we have to discuss. Okay, so if I go to first, what is dual stack, if I go right, so if I go to what is dual stack and even what is IPv4 and v6, like both almost same, right? So basically what is dual stack, right? Dual stack is nothing but using IPv4 and IPv6, right, together. That is called dual stack. So why, right, why we are using it? So IPv4 addresses are limited basically, right? So IPv4 addresses are limited, but IPv6 provides huge address range, right? Address space, we will get it. Address space, we will get it. Also, for example, why still we use IPv4? We can go for IPv6, right? But but it's not IPv6 not fully compatible, because we are still using IPv4. So the compatibility we use like IPv4. And this is like a future way, right? So this is like a very simple thing, right? Dual stack and IPv4 and IPv6. So then if I talk about what is network and network interface, right? So if I go to that way, what is network and network interface? So basically network interface, right? Network interface, you anyway we all have the laptop. So if you want, each laptop we have, there is a hardware, how it's like a RAM and hard disk. We have the physical NIC, network interface card we have, right? So that is network interface. um, so also we also have similarly like virtual NIC, like for example they have like something like ENS1 bond 0 bond 1, because in the cloud if you wanted to use, we need to use virtual NIC, right? Same like hardware, how we take it from the cloud, like a machines, right? Server. So the same way virtual NIC, right? So that is called a network interface. So basically interface is the entry point, right? Entry point. See, for example, if you wanted to uh, connect Wi-Fi, so we need a NIC, or like if you wanted to use LAN, so there is a LAN port it's required, which is connected to NIC, right? So that is what the interface. So for example, we have the there is called VLAN, right? So that also comes to here itself. So I will just merge this. Okay, so what is VLAN as well, right? So for example, um, we have one NIC card, physical card, which has the port, right? Port. For example, there is a LAN cable which we will connect to the laptop, right? Similarly, we have the n number of port. So each port we will have the separate ID, right? VLAN ID. So that is that why we have a different port, right? To have the multiple separation of the network, right? See, for example, one cable we will just use for security, one cable we will use for isolating storage separately. So that is what this is a VLAN, and this 100 is VLAN ID. For example, NIC 1, NIC VLAN 100, right? NIC 1 VLAN 100, and the same NIC we have the another port that we are using like a VLAN 101, I mean 101, and then this is what, right? VLAN. So VLAN is basically virtual separation, right? Virtual separation of network. Yeah. So then what is gateway? So each router that connects to the network. So what is network, right? What is network is connection, basically, right? Connection between systems, right? So router that connects to network. So basically we use this to reach outside network. So for example, in terms of OpenShift, node, then gateway, then internet. Okay, so this is just for you to understand in terms of the OpenShift. So multus is nothing but multiple networks per pod, right? So when dev team they do the deployments, so they use multiple networks per pod based on the usage and workloads, right? In basically the telecom domain, so we use multiple networks concept. So multiple networks per pod, because some domains the default network it's not enough, so we need a multiple network. So for example we call it as for example eth 0, it's a default network for example. So another one if we have, that is secondary network, we can call it as. So this whereabouts, srio, and then static, right? These all uh, having a different purpose. For example whereabouts, it's a secondary network, secondary network type, and then this all secondary network, but whereabouts it's a one of the type. And again srio is so single root, right? Single root input output virtualization. So this what happens is, here if you use this network type, this is direct communication from the pod to nic, right? See for example we have the pod, and then we have the physical nic net card, then directly network. So why we use this network type is, it's a high performance purpose, and then low latency, because it's a direct communications, right? So directly part to physical nic, and directly then it is connects to network. So low latency purpose. Then we are going for what is ovn and sdn, right? So ha proxy we have discussed, q proxy we have discussed anyway. So ovn it's a component which will use to do the pod to pod communication, right? So this is like pod to pod communication we use. sdn is software defined network, ovn is the underlying overlay network which will by default used to having the pod to pod communication. q proxy, right? So handles service route. This is again load balancer used by OpenShift router. Manages the external traffic. Exposes the service externally, because as soon as the people have done the deployment, they will expose their application, so that it automatically creates the DNS to the user. After creating a DNS, only user can able to communicate to the pod, right? So this will expose the application via URL. So this is like basically when we are using a secondary network, multi network, right? So we have to attach the rules, network attachment definition, which will define the rule, right? So there are many things will come into the picture. Network attachment definition for each namespace. So this is used by Multus. Port is nothing but it's a application endpoint. So switch is, we can say this will connect the device in the network, connects the devices in the network. If this get fails also, there may be a huge problem in the master. Service and service IP, right? What is service? Service, it's uh, logical access to the pod. Access to pod. Service IP is virtual IP, nothing but virtual IP or cluster IP, which we has. This will do the load balance internal traffic. Yeah, so this not required. This will be like here only. Internal service IP, right? So virtual IP or internal service IP, that is the cluster IP basically. So communication flow components, right? Uh, User, then load balancer, then HA proxy, then service, then pod. This we can. So pod to pod communication is happening. So for example, pod A, we have the image, right? So using the Linux kernel sharing, that will communicate to the same node, the another pod, right? Pod B. So pod to pod different node, right? Then pod A, then we discussed about OVN, which is the default network in OpenShift, and then it goes to network, and then again it goes to OVN, and then because this is like another node, right? So this is a node A, node 1, then in the pod, right? So then node 1, then in the node 1 pod it will go to OVN and then network, and then node 2, then like OVN and then node 2 and then pod P, which is the second pod which will communicate, right? So this is another thing. Yeah, so that's all. Today we discussed about the the simple communication flow, which is like I can discuss like this, right? From DNS, load balancer, route service part. Yeah, thank you all.